Okay, can you all see my sharing screen here?
Yes.
All right, so I'm going to start. Okay, a very good morning to everyone. So today, this morning, I would like to present with my title called Process Control in Torrefactions, Design and Experimental Investigations of a Custom-Made Oven using a fuzzy logic algorithm. Okay, background studies. Torrefactions actually is a thermal pretreatment that enhance the biomass properties by heating it without oxygens between 200 to 300 degrees Celsius. Conventional, which is a normal thermal treatment. So actually they dry it any biomass with the oxygen environment. So there will be a difference without the oxygens and oxygens. And researchers demonstrated that this torrefactions is an excellent method to dry the MSW, solid waste, specifically food waste, because we know that nowadays food waste is a problem, a lot of food waste, like also plastic. And actually, we can convert all these food waste or plastic into the biofuel productions. But of course, that we need to do pre-treatments before to do the conversion. Torrefaction is an isothermal pyrolysis process for the municipal solid waste that reduce the moistures and the volatiles, enhancing the fuel's properties like the density and granularity. Yeah, we actually did a lot of market study. Fuzzy logic control, all right, is one of the method of control system design based on the fuzzy logic, FLC. So it is not no need a very precise mathematic models such as a PID controllers, and FLC can handle the systems. Yeah. We can see that nowadays in the market, a lot of applications of our home appliances, automotive, robotics, aviations, and consumer electronics, all these things, they all use the fuzzy logic control FLC. Now problem statements. Yes, carry out on the study on high moisture contents will influence on the biochar and bio oil. And also, according to Cheng, there's a lack of commercial lab skill torrefaction machines. It's very hard to find, especially for the lab skill, which remains a challenge for the researchers in this field because it's hard to find one of the parameters that we want to study. Yeah, to see a certain of parameter, what is the result, the effect to the biochar or biofuel. Also, most commonly used control method is PID because in the market there are a lot of controller which is direct use PID controller. Because we need a heating rate. Heating rate is another one of the parameters that we can study. So PID not able to custom find to tune the heating rate that we want it. So that's why we need to design a new control system. And also PID not as good as FLC. And a lot of people that try before use Jingle Nicholas and the other methods, try and error and to tune a certain constant value to get a not so high of overshoot of the control. Now, why FLC? Cost effective, simplicity in tuning, and potential industry adoptions, and also performance improvement in the system. Advantages of FLC, able to handle a system with a high uncertainty, more precise due to the human-like intuitions. Accurate and complicated mathematical model is not needed. The objective of this project, develop a GUI fuzzy logic based on temperature control and heating rate using a Raspberry Pi platform. We want to study also determine the transition response of rise size, setting time, and overshoot by this FLC algorithm. Conduct an experiment using 10 fuzzy membership rules on the custom built oven. We also did the verifications of the monstrous pre-treatment process from the market ICA oven. This is a industry. It is not a torrefaction. It's just a thermal oven. So we want to compare, and also with this custom made furnace. There are some literature reviews. We know there are so many different control methods. PID, model prediction control, adaptive control, neuron control, robust control. Yeah, this all of the control algorithms actually generally require more computations. Need a high-end, a better high performance of the controller. Yeah, and also need the expertise people. Right, need expertise people to are very good in the mathematics. Yeah, in order can use the mathematic equations and to achieve this different control algorithm. So FLC actually no need without a mathematics skill. All right, it's very simple. Just use if else, mostly if else, and very easy to implement. Yeah, we compare the advantages and disadvantages. So at the end, we decided to use the FLC. When we look where we want to apply for the FLC, yeah, we need to know the theory in behind the FLC, FLC concept. So we design the whole FLC control algorithm based on this theory, this block diagram. Now, after that, Raspberry Pi. Yes, Raspberry Pi also like a mini PC, and is very low cost actually compared to nowadays. Everyone want to cut cost, so Raspberry Pi is a good consider. And we also use the Python programming code. Why we use Python? Even now that we know GPUs, platform, the NVIDIA, and also quantum computing, they are all using the Python programming code. So we move on to use a Python for this system design. Yes, one of the researchers already completed also temperature control using a fuzzy logic methodology. Yes, so this is the custom map of the furnace, torrefaction furnace. So there's no controller, so we need to come out the controller. Yes, this is a 10 rules membership that we came out with the structures to control the temperatures. This is the temperature. This is a electric power control. This is SSR to control the high voltage. It's about up to 25 amperes because this furnace can up to 1000 degrees Celsius. This is a sensor to detect the internal chamber temperatures operations. Yeah, this is a Raspberry Pi controller. This is a safety circuit diagram because if it's a very high temperature, so we need a safety switch to control the electric. Analysis of the system. So this is what we focus on the rise time, setting time, and the overshoot. Also to study the after the treatment, what is the initial moisture control, moisture content before and after according to the ASTM standard. Yes, this is market current industry. All right, and this is the customer. This is, I think, about the time is about 9K, and it's only a thermal treatments up to 300 degrees Celsius. So this one we custom make is less than 9K. All right, and can up to 1000 degrees Celsius. Result. So we came out with this GUI, graphics user interface, very flexible. We can fine tune how many hours we want to control and what is the temperatures we want to control also. And fuzzy logic control, right? This is a different mode that we can try out. We can try other controller also in the futures. Just need to top up the programming. So we get the linear equations which able to we use the PWM. Is another kind of frequency clock generation to the AC power to control the power. So that this mathematical equation actually we put into the programming, so that depends on what user what heating rate user want to use, because different heating rate we can use to study the is one of the parameters any effect to the properties of any biomass. And also this is a different 10 membership of the PWM, yeah, that we're going to use to control the temperatures. Yes, this is a Fuzzy's rules. Yeah, without the FLC control. So this is we want to control 100 degrees Celsius. You can see the blue color, it overshoot very high. All right, to 200 degrees Celsius also very high, and also we can see the fluctuations after the setting time. So without the controller. So when we apply this FLC, we can see that totally there's no overshoot, slightly, I think about 1% only. All right, you can see that it reduced a lot of the overshoot. Yeah, so this is a table of the result without the FLC and with the FLC. We can see the overshoot is very high, 33%, especially for the 100 degrees Celsius. So when we apply the FLC, it's reduce the overshoot less than 1%. The highest is only 200 degrees Celsius, 1.8, but it's actually reduced a lot. From 18% reduced to 1%. Yeah. Yeah, but the rise time slightly will is extended. All right, it was extended after rise time. We verified the MOSHES pre-treatment process. So actually, we got it almost a similar percentage. Market about 51%, customer about 52.3%, and for total fractions is about 54. Conclusion. Yeah, fuzzy logic was successfully implemented on the Raspberry Pi platform. Overshoot was successfully to minimize, and future work that improve setting time, rise time for higher temperatures, integration of IoT and AI features into the system, and can do the characterizations of a dry MSW. Thank you for the UOW Malaysia provided the internal grant. This is a code UOW MKDURG 2023 and 005. These are the references. All right. Thank you very much.
Thank you, Mr. Neslan.
Yeah, most welcome. So
Okay, yeah, we open the floor for Q&A. If there's any question.
oh,
Thank
okay.
you,
Well, no.
Dr. Haja. Okay, so it seems like no question from the floor. We can move to the second presenter, it seems.
Okay. Thank you very much, everyone.
Thank you. Thank you, Mr. Neslan, for sharing.
Yeah.
Hello.
Hi, Fazli.
Hi. Should I share my screen now?
Yes, yes, you may share your screen.
All right. 1 second. All right. Can you guys see?
Yes.
All right. Hi. Okay. So my name is Fazli, and today I will be presenting my topic of investigation of processing mechanical properties of PLA tapioca starch biocomposite filaments for additive manufacturing. So basically what that means is, so the work that I do is specifically in the field of advanced materials. So what that means is green materials. So I'm working with PLA and tapioca starch, so PLA is a biodegradable plastic, and tapioca starch, well, we all know that we have, well, abundance of it in Malaysia. And what I want to use this material for is in the field of 3D printing. Right. So as I said, PLA is actually quite common now in the market, and a lot of people are using it. Like I said, it's biodegradable, it's green, it is very strong, versatile, and it can be mixed with a lot of other materials. So not a pure 100% PLA. You can also mix it with, so in the market right now, there's potato, there's wood, so a lot of different variations that you could do. My specific combination that I'm doing is with tapioca starch. So we have a lot of it in Malaysia, and the one that I'm using, so sometimes I get questions like, are you not scared of it being a food source? Because in times of emergency, we might not want to use tapioca starch as an alternative to a material. But the one that I'm using is industrial grade, so the ones that are not eaten. So most of them are being thrown out. So you can count them as being waste. So a biocomposite is essentially just a mixture of two materials, and the reason why I'm combining these two materials, even though PLA is already very good on its own, is because PLA by itself, even though it's strong, it is very expensive and quite hard to adopt in the market with those prices. And yeah, so that's what I hope to achieve with tapioca starch. So tapioca starch, well, because this what I'm presenting today is a part of a bigger topic. So what I'm doing is focused on 3D printing, but other works have been done on injection molding, which is the common mass production technique. But right now, I'll be focusing on the first step of 3D printing. So what do we need to 3D print? It is to come up with the filament, the raw material. So before that, let me just explain to you how that's going to work. So as you can see here, this is a filament, the equipment to fabricate the filament, the raw material of the 3D print. So first of all, we have the hopper. So we have to put in the raw materials in forms of pellets, and we have to melt it down all the way to temperatures of up to 200 degrees Celsius. And once that is melted down in the screw, it will come out as fine filaments within the diameter of 1.75 mm, and that is what we use to extrude or feed into our 3D printer. So the 3D printer that we are using in UOW, we have a few, but the one that I'm using is the FDM. So as you can see here, there is a green feeding material that goes into the gears, and it is deposited onto the bed. So that is the most common method. There are other methods using UV, using laser, so known as SLA, SLS, but those ones are a bit more complicated and they require a lot more energy as well. Yeah, so the most common one is FDM, and that's the one that I'll be using. So what are the problems, right? The problem statements. So as I said, there are a lot of research being done on other materials, but not really on this specific combination, and especially not there's none right now on 3D printing. So that is the first thing. The second thing is, so in order to come up with the filament, a lot of things need to be studied. So first of all, what are the parameters? So at what temperature it's going to melt, at what temperature is it going to cool down, and then also the RPM of the speed of how fast you can come up with the filament. So those are all things that need to be studied. And also finally the different, so because we're not sure how suitable PLA and tapioca starch is for filament making for right now. So we'll be focusing on what are the ratios of PLA and tapioca. So in this specific study, I'll be doing 80%, 80 to 20% PLA to tapioca starch, all the way down to 70-30 and also 60 to 40%, and how they affect the printing, the extrusion process. So yeah, so first of all, coming up with the filament. Second of all, to analyze the parameters, behavior of the filament while extruding it, and also to find out the difference between the visual and mechanical properties that these different ratios will have. So this is an overview on how it looks. So we start off with the tapioca starch. So they come in very fine powders, but we have to get them into a standardized, what do you call it, sizes. So we sieve them down, and then once we sieve them down, we have to dry them to make sure no moisture is there when mixing with the molten plastic. And so with the molten plastic, PLA is known to be very brittle. So what we do is we add a bit of plasticizer, that's the epoxidized palm oil in this case, and then also the compactilizer, because tapioca starch and PLA, they're not really two things that are meant to be together. So it might not be as strong. So in order for them to bond well together, we have something called a compactilizer. So in this case, we use malic anhydride. So overall, what this process is going to do is it's going to fuse everything together homogeneously, and also make it flexible enough to be made into a filament spool, and also, it's not too brittle, so the compactilizer helps with that. Yeah, so that's how we come up with the filament. We mix, and then we have to extrude it, and then the filament is being fed into 3D printer to see how well it can extrude, how well it can print, and also lastly, because we're comparing different compositions of PLA and tapioca starch, we want to check the mechanical strength as well. So these are the equipment that we have in UOW. So everything's in-house. We have everything in the lab. So we start off with, to mix everything together into a homogeneous mixture. We have the Sigma blade mixer. So that itself operates within 100 to 170 to 185 degrees Celsius range. And the speed depends on how the room temperature as well, but generally speaking, we melt it at the RPM of 30 to 50 RPM. And then once we have the mixture, we can't straight put that into the extrusion, the filament extruder. So we have to let it cool down first, crush it, and then we come up with fine little pellets, which will then go into the hopper of the extruder. So over here, we ensure that the filament comes out with the diameter of 1.75 mm, give or take 0.1 mm, higher or lower. If it's any higher than that or lower than that, then there will be complications in 3D printing, because too thick means that it cannot feed into the printer. Too thin means that the gears cannot identify it there. So it needs to be within this range. So the printer that we have is the Prusa i3 MK3S. So as a general rule, I use these parameters to start off. So I got these from other PLA and wood, for example, studies. So that I use these as a baseline. So that includes the nozzle temperature. So that is, and then also the bed temperature, layer height, and print speed. And finally, the ETM machine is the one that's used to measure out the mechanical strength. Okay, so here is what it looks like. So the composition, as I said, is we look at 18 to 20%, 17 to 30, and then 60 to 40. So this is the extrusion line that we made in-house at the uni, and the machine is, so the parameters that we found for the machine that works for generally works for these compositions is as the following, and I'll go into detail more into what exactly each ratio, what each composition, what works the best for it. And so this is how it looks like on the dial gauge that shows the thickness, and these are the filament that goes into the 3D printer. So as I said, each ratio, each composition is going to have its own way of behaving with extrusion. So here we have for the 60/40, they perform better at a slightly lower temperature. So the feeding temperature, the barrel temp, and the cooling temp, they're slightly lower than the rest because it has a higher content of tapioca. And so what that means is it gets burnt easier. So a general rule, while I was extruding all these filament, once it gets a bit too dark, the color shifts to a darker brown. That's when I know that it's burnt. So that's how I determine whether it's suitable or not. And also, if it gets a bit burned, then it gets too brittle. So we don't want that. So it's very important to keep the temperature within the right range so it doesn't burn and it doesn't get too brittle that it can't print. And for 1720 and 1820, they're roughly about the same, not much difference in extrusion parameters. So we can see that it's around 145 feeding temp, and barrel temp is around 175, 180. So only a margin of 5 degrees, and the cooling temp is the same. And so 1820, the extrusion was much better compared to the other compositions because of the stability is much better because PLA is known to be stable while extruding. So that's the reason why 1820 performed better while extruding. So not much issues there. As compared to the 60/40, it needs a little bit more touch or a little bit more customization when extruding it because it's not always as consistent. So even though these are the parameters that it shows that it comes out the best, but for it to come to this point, it needs a bit more time before it can consistently come out. And yeah, so just as a visual observation, the 1820 comes with a more transparent look, and that is a given because PLA itself is more, it is transparent by nature, by how they manufacture it. So as we go higher in content of tapioca starch, we see that it gets a lot darker. So that shows itself in the final printing as well. So from lighter to darker. And the finishing is much smoother on the 1820 as well because of the higher PLA content. And right here is where we see the mechanical performance. So we look at 3 different categories. First of all, tensile strength. So tensile strength is what we use to determine how strong a material is. So we can see that 1820 is much higher compared to the other ratios or compositions because of the higher PLA content, and 60/40 is quite low. So 70/30 is actually the middle ground, and by which the current market operates within. So 14 megapascal is not too bad. And next we look at the elongation. So even though it might have strength, how well does it do in terms of stretching or in basic terms? So 1820 is not bad actually. It's actually the best one. So that stretches by 1.9 mm compared to 60/40, which is 1.2. So the 60/40 was a little bit too brittle because of the higher tapioca starch content. And then lastly, it's the Young's modulus. So that's just a ratio between the tensile strength and the elongation. So the ratio is at the highest at 1:56 for 1820. So that means it has the best strength to elongation ratio, and the lowest one is 7030. And so here is a pilot, was the pilot 3D printing. So as you can see, initially it comes off, it is quite hard to get a smooth first layer. So that was a major issue that I had. And secondly, the gears. So because the material is being clamped and fed into the printer, it might be the gears were a bit too strong, the clamp I mean. So that was also an issue. And PLA tapioca is a bit more softer compared to other materials. So that was an obstacle that we had to fix. And also, even when we had the first layer, it was not as clean initially, and the outer perimeter, and also there was specifically an issue with it sticking to the bed, and also not sticking onto the nozzle of the printer. And along with that, we had to make sure that it could finish smoothly all the way from the first layer to the last layer, and we found out these are the best parameters for printing the material. So that the nozzle temp was set at 220, bed temperature, which is the temperature of the platform here, set at 70 degrees Celsius. And the speed of the printing, the material favored a much slower speed compared to normal PLA. So normal PLA could easily print up to speed of 100 millimeters per second, but this material is a bit more sensitive, so it performed better at lower speed. And then the layer height. So the layer height determines how thick each layer of the material is deposited onto each layer. And we found that 0.2 was a sweet spot for the material. And yeah, so to conclude, we did successfully extrude different compositions of PLA technical starch for the filament in 3D printing, and then we found which one performed better in terms of mechanical strength, and also even 3D printing it, and then the final extrusion parameters for each material, each composition. So that is all from me. These are my references. Thank you very much. Are there any questions?
Thank you, Fazli. Okay, is there no question from the floor?
Thank you.
I Okay, so I have a question.
Yes.
Sorry,
For me, right?
yes, for Fazli.
Okay, yeah.
Do you think that there is any substitute for the, you said that tapioca, right, just now? So is there any substitute for tapioca itself?
For tapioca itself, yeah. So there's a lot of other different combinations, like I said. So the most common one right now is wood. So that's wood and tapioca starch. I'm not sure what the ratio exactly of PLA and wood, but that is a thing right now. And also potato and tapioca starch, that's quite common as well. And my supervisor, Dr. Nishata, she's actually working on another combination, which is PLA and rice husk. So rice husk is also another issue that we have in Malaysia, where that's what we do with the rice husk in the field right now is we just burn them because there's really no usage for it. So yeah, so my supervisor is doing another topic on that where to make 3D printing filament as well. Yeah, so yeah, there are other And then if we're talking about conventional materials, there is ABS, the PLA itself is very common. And then, yeah, plenty of other substitution material as well. But those are pure plastic. Yeah.
All right. Thank you, Fazli, for
Thank you.
sharing. Okay. Well, you have Nushara. You can start now if you are ready. Are you muted?
Yeah. Hi, can you
Okay.
hear my voice?
Yes.
Is it clear? Clear.
Yep.
Yeah. All right. So let me share my slide first. Another slide. Okay. Right. Can you see my slide?
Yes. Yeah.
Yeah. All right.
Mm.
Thank you. Okay. So, hi, good morning, everyone. First of all, let me introduce myself. I am Sheila from School of Computing and Creative Media. And today I'm going to share with you about this one research paper related to optimizing depression's predictions model, specifically using a stack example approach with weighted feature important. So together with me, completed this research were first my students, Debbie, and then my colleague from SCCM, Mr. Gerard, Miss Cindy, Miss Siti Fazila, and also my fellow researchers from UITM, Dr. Mahayudin. All right, and also this research funded by this conference. I went to the conference last May and was funded by BGRC, UOWM Malaysia, and it is a part of Internal Research Grant 2024. Okay, so, okay, so today I'm going to cover from introductions, methodology, result and discussion, as well as the conclusion. And let me begin by addressing the issue for this research, which is regarding the depression. It is a major mental health issue affecting students where there are a lot of factors that can contribute to have this depression, such as academic pressure, social support, and also personal factor. So depressions can actually lead to severe consequences such as suicide. And based on previous study, depression is actually one of the leading cause of death among young people. And here comes one crucial question. Can we detect depression early enough so that before it escalate? And this is very important because early identification can actually we can actually prepare for a better intervention and also to prevent from escalation. And here comes the role of machine learning, where it can actually offer promising result to address the challenge of mental health prediction. And for our study, our aim is actually to evaluate machine learning model, especially related to stack example approach. Not only that, we also aim to analyze weighted features important to identify the most significant predictors for depression. And this is actually our research workflow. I will explain one by one. And the first step is actually for data acquisition. And after we did our review based on existing data set, we decide to choose this one data set related to depression student. And this data set, I think, collected by Jamitco 2024. This data set consists of 502 observation with 10 features. And these actually the features that involved in this study. And also the target variable is whether the students have depressions or not. And then the next one, for data preprocessing, the first step is to check for missing value and outliers. And then we go for the normalizing and scaling numerical features. And finally, for categorical variables, we use one-hot encoder. And then The next one, before that, we apply 5 different machine learning models to for evaluations purpose, and we assess the performance using accuracy, precision, recall, and also F1 score. And the next step, basically, based on these 5 different machine learning models, we choose the top 2 classifier based on their F1 score. After we choose the top 2, we apply stack models. Where stack model, basically, we use the combination of 2 different classification models with the logistics regression meta models. These application of stack model basically to enhance prediction accuracy by leveraging the strength of both base model. Then the next one, after we got the performance for the stack model, we came up with the feature importance calculation, where for this research paper, we come up with one calculation, a simple calculation with using the weighted average feature importance, some of the normalized features important based on the 2 different top classifier, because for your information, stack models, we cannot come out with feature important. So we rely on the top 2 classifier, but which one should we use? Is it the first one or the second one? So to utilize both methods, to utilize both classification models, we try to come out with weighted average feature important by using this calculation. And then finally, we visualize the result by using bar plot. Then, before I show you the findings, this is actually the distribution for the target variables. As you can see, consists of balanced distributions, where for those who have depressions, 250 records, and also for this one, no depressions. And then for those who have depressions, 252 records. Okay, now we move to the performance comparison. Like I said to you guys before, first we look into 5 different classification models: random forest, XGBoost, extra trees, gradient boostings, and also like GPM. So out of these 5, we figure out that XGBoost and also like GPM perform the best compared to other classification models. And we use these two to be included under stack model. And finally, the result for stack model basically outperform other models with 93% of accuracy. And this actually the result for the feature important. So as you can see over here, the top 2 factors are academic pressure and also history of suicidal thought. So this one based on data set that we use. Okay, as for the conclusions, the first one, this study actually highlight the effectiveness of ensemble learning model as part of machine learning model, and especially to predict the depression. Second, we can see that the stack model, which using XGBoost plus with the like GPM basically outperform individual classifier. And finally, feature importance analysis reveal key predictors. So like I showed to you guys before, the academic pressure, basically the top factor that contribute to depressions among students. And for future works, future researchers basically can collect more diverse data set to improve the model accuracies and real-world applicability. Okay, when we collect the new data set, we can include varied demographic groups to improve the generalizability. Okay, and then we also need to ensure ethical practice during data collection, because the data set that I use basically existing data set. So we don't know much about how actually this data had been collected before. So it will be good if, let's say, we have our own primary data collection. So we can control the data quality from the beginning. And finally, we have to assess the broader impact of the model across different population. So for your information, after we did this research, my team basically come out with, we planned last time to come out with one survey, primary study to collect related data sets so that we can assess mental wellness among students. So we collected 312 responses across various university and college in Malaysia. So for your information, my students came out with these two projects to somehow show the data inside based on the data set that have been collected. So the first projects under FYP2 semester June 2026, you can access this dashboard by looking at the GitHub link over there. And also another project for this semester's Data Science Toolbox project. This group of students also come out with students' mental wellness dashboard based on data set that have been collected. And finally, for the current work, we are trying to develop an efficient machine learning model using the collected data set to predict student health wellness. So previously, the projects that have been done by the student just use standard machine learning model without any improvement in terms of the machine learning model. So here comes our job to look further and try to figure out how to make the machine learning more effective with the data set that we already have. Okay, I think that's it from me. Thank you very much. Any questions?
Thank you, Sheila, for sharing. So
Thank you.
we anyone
Okay.
for any questions for Sheila? Okay,
Hello,
John.
hi. I have a question for Dr. Sheila. I'm
Hi.
John. I'm
Hi,
John
John.
John from SCCA. I just want to ask Dr. Sheila. Basically, when you said that the students are about 500 of them, right? And then there is 250 of them that is actually they have symptoms of inclination towards like depression and all that. So that's like half, like 50% of those students. So which is actually high. And also, I mean, we ourselves in our classes or when we engage with some students, we tend to see that students nowadays they have majority of them have this inclination. So can I know how do you choose? I mean, how do you guys choose the 500 people? Like, do you know they already have some sort of symptoms before, or how do we gather them? So that's one question. And another question is, does these students involve students from UOW, or are you doing a separate study for maybe UOW students maybe in the future? So this is something that these are my questions.
All
Okay.
right. Okay. Thank you very much, John, for your questions just now. So let me answer one by one. So we go for the first question. So just to remind you back that the 500 student basically based on existing data set. So that's actually secondary data set that we found from Google. And it's not some things that our team collected before. So in terms of how they actually figure out that 250, we don't have much idea on that. But for your information, this study basically like preliminary study for us to actually figure out what actually factors that contributed to depression. So that when we want to collect our own data, we know which one to be included and which one actually beneficial for us to collect for our own student. And continue from there. After we did this study, like I showed to you guys just now, we did collect data for 300 plus students, 312 students. And that students, basically, most of them from UOW Malaysia and also some of them from other university. So the follow-up from there, what happened is that for our own survey, how did we measure whether the students got depressions or not? So our first stage, what we did, we actually give them like establish mental wellness question survey. So I'm not sure whether you guys familiar or not. We have many many survey that had been established, that had been verified by psychiatrists out there. Okay. So we can use, and after we answer several questions, we can get the score. So once we hit certain score, then it proves that, oh, this student basically under this depressions condition or under anxiety condition. So that's how we map the features with the target variable, whether the students actually falls under depressions or not. So that's about our survey questions. Okay. And we did this to get the 312 responses, and we try to predict which will be included in our next study with using the same technique and also more advanced technique afterward. So that's how we map between whether the students got depressions or not. That one for the first question. And I also had a discussion with one of our team members, new team members, which is Dr. Gunasekaran from IMU University. So he actually quite well versed in the medical data analytics, and he also suggests to somehow use their expert over there to come up with more survey with more to collect data, more quality data by assess the students one by one. So we give them we give them like demographic questions about themselves, and certain questions that related to the factors contributing to depression, and their expert will actually determine whether that particular respondent got these kind of mental issues or not. So that's actually our next step. So further project will be with IMMU, hopefully. And then for the second question, John, what is the second questions? I forgot.
No, I asked second question is actually for the first one, I think you're doing like the first question, the answer, yeah, I understood, and I think you're doing a great job in that. And the
Thank
second
you,
one,
John.
I said that is it any student from UOW? Are you doing a future
Oh, okay.
study?
So, okay, thank you, John. All right, like I
Okay.
said just now, the collected data basically involving UOW Malaysia student as well as part of the respondents. However, as of now, we don't have any plans to focus only for UOW Malaysia, because maybe we aim like a little bit high to have like these early detections for depressions, not only for UOW Malaysia. Maybe we're going to go like either private universities or government universities. We're going to check whether there are actually difference in terms of factor contributions for private or government university, public university. So if let's say nothing much, so maybe we can come up for overall universities in Malaysia, as long as that particular, those who want to use this early detection is the students, then they can use. So that's my answer. Mm.
Thank you, Dr. Sheila. Thank you.
Right, thank you, John. Any other question? No? Okay, I pass back to Farah. Farah, you there?
Thank you, Sheila. All right.
All right,
So if
thank
there's no
you.
question, I think we will go for a short break. I will come back at 5 minutes for the next presenter, Dr. Tan Jia Yang. Alrighty, so we'll see each other at in 10 minutes.
Okay.
Thank you, John.
Boleh, boleh, I boleh. Ah, boleh. Sekarang panas kan? Kenyang dah makan. Lah kenyang lah pula makan. Cepat kenyang lah makanan dia. Nak kata nasi semua cukup. Ini sih bagi pakai dia.
Alrighty, so we can start back our session. Dr. Tan Jiaxiang, are you ready?
Yes.
Okay, you can share your slide. Thank you.
Okay, so good morning everyone. So I'm Dr. Tan. Okay, so the title I'm gonna share today is the hybrid random forest and attention LSTM for the enhanced NILM. Okay, what we call is a non-intrusive load monitoring system in the residential energy management. Right? Okay, so like today's actually our TMB, the smart meter, especially now in urban area now. Okay, I think most of us already changed to the newest one. Okay, that maybe you can see your electric consumption every 30 minutes interval. So actually this already improved a lot. Okay, compared to like previously, we only saw the usage once a month or maybe daily. Okay, but now even with the newest smart meter, actually we are still not able to like visualize which appliances are actually consuming the energy. Okay, so the meter only tell us the total consumption, but actually it doesn't tell us like what is the electricity is going. Okay, so we can see actually the study show that we can reduce our bill, okay, like up to 20% by only detecting the malfunction appliance. Okay, and then although it's require real-time feedback and also the detailed analysis, okay, that we can alert the user immediately. Right, and then another one is if we have the appliance level monitoring, then actually also can reduce the energy cost to 12%. Okay, rate reduced by 12%. Okay, compared to like we only rely on the monthly bill. Right. Okay, so first we can share about what is the concept of load monitoring. So actually in general, okay, load monitoring we can categorize into two main categories. So first one is intrusive load monitoring, or we call ILM. Then another one is non-intrusive load monitoring, right? NILM. So as you can see from the diagram, actually the ILM is considered as intrusive method because it require the sensor to like install directly on each of the individual appliance. Okay, and then yes, the IRM actually it can provide quite accurate data, but it's actually is not very practical. Okay, for residential because like it will cause a lot of inconvenience and then also will lead to privacy and also the security concern. Okay, and then for NILM, so the concept is like to disaggregate from the total household energy. So this one is we can measure on the single point, okay, into the individual appliance. So means that actually we are just from one main power entry, okay, normally is from the meter. Then it can estimate which appliance is operating. So when it's operate or when it is operating and how much the electricity is consumed, right? And then is less the privacy concern also. So these are some of the NILM that facing the challenge. So the first one is the multiple appliance is often operate at the same time. So this will cause our electrical signature overlap. So it also may difficult, okay, to distinguish like which power consumption will belong to which appliance. Okay, and then the second one is like many device, it will have multiple operating state. So for example, like hair dryer or the washing machine. So this different state, it will produce like different power patterns. And then this also will like the variability will also cause the classification or recognition more complex. Okay, and then the last one is the transient spike. Okay, like during the startup or the mode change. Okay, so this also will confuse the model. Okay, like some appliance, it will generate a sharp spike, okay, when they are first turned on or when they are switching the mode. So this spike will also cause some misidentified, right? So these are the proposed system. Okay, so these are the overall flow chart, the basic idea. So actually you can see the the flow chart summarize the full pipeline. Okay, actually it's from data collection all the way to the training and prediction. Okay, so for our data collection actually is very simple. Okay, so we only use the Arduino Uno together with the CT clamp sensor, okay, to measure the uh, current flow through the main meter. All right, so once the data is collected, then it will go through the pre-processing, and then after pre-processing, it will perform the event detection and also the feature extraction. Okay, like to determine whether the signal is correspond to, for example, like steady state or transient state. So we will split the system into two models. So the first one is to the steady state. Okay, and then another one is for transient state. So during the prediction phase, we will check first if the incoming signal is either transient or steady. Okay, if you recognize first, then we just go through the model and then see whether it's able to recognize and then update the appliance status. Right? Okay, so these are the two different scenario algorithms. So the first one is when you meet the transient scenario. Right, so this concept is when the new data is arrived. So the system will first check whether the signal, okay, is belong to transient event. So if yes, then we will apply the model, okay, to classify the appliance. Right, and then the second one is the multi-state, and or concurrent, or what we call is on together. So this algorithm is when the appliance run at the same time, or the device that operate in multiple state. So when you change the state, okay, when it detect, then it will go through this algorithm, okay, to see whether there is a match or not. Then if yes, then it will update the appliance. Okay, so this will help us like to detect some short or sudden spike. Okay, right. So these are the case study. Okay, so we selected 10 different household appliance that I believe is we are commonly used. So we are recording with the operation of 120 seconds, okay, which is 2 minutes. And then within this duration, there's a total of 36 appliance event. Okay, so we will switch on, switch off, change the, for example, change the state of the hair dryer. Okay, and then maybe we will do like, for example, kettle and oven we will on together at the same time to see whether it's able to recognize or not. So for the data collection, uh, as what I said just now, so we only use the Arduino, okay, to configure and collect the 3750 data in 1 second. So in Malaysia is 50 Hz sampling frequency. So after calculate, we get one electric cycle is about 75 data point. Okay, so it will give us the detailed waveform, okay, that you can see from the left. Okay, so the waveform information, we will do some pre-processing and linear regression, okay, to make it to become the right one, okay, to make it more stable. And then over the 120-second period, we can get about 6,000 data points. Okay, so in this case, we will also intentionally combine all three scenarios, okay, into the data set. So which means is the multi-state one. Okay, for example, the hairdryer, then on together operation. So we will shoot two or three appliances together, and then also the transient event, okay, which means is the sudden spike, right? Okay, so these are the event that you can see. So it's about 120 seconds, which is 6,000 data point. So as you can see from the graph, we highlight how the appliance behave over time. And then you will notice many event actually is involve the two or three appliance that switching on or off at the same time. And then it also create some overlapping signal. And then another point is the hairdryer. Okay, so you can see at the left, the hairdryer hit one, then it will straight away change to hit two, okay, without turning off the hairdryer. Okay, right. So these are the results, okay, for the proposed system. So you can see overall, actually, the model is still quite okay, still satisfactory. So across the 6,000 data point, actually the system is achieved low MAE and RMSE. So MAE is the mean absolute error, and then RMSE is root mean square error, right? So this system also able to identify all the 10 appliances, okay, including those with multi-state behavior and also those with the operating together, right? So if you look at the disaggregate result, okay, at the bottom table, so the result from each individual appliance, you can see almost all the appliance achieve a very low value. Okay, so which means the predicted power pattern actually is closely matched with the actual measure pattern. Okay, so this is still okay, right? So we can see here. Okay, so for the disaggregation result, uh, you can see the three cases. So you can see several highlight region, okay, that operating at the same time. Okay, for example, you see on the left, so the hair dryer and the blender are switched on together. So hair dryer is considered as multi-state, and then blender is considered sudden spike. So when you switch on the blender, it will have a sudden spike. Then it's still able to recognize. Okay, and then the middle one, okay, the electric cooker and also the vacuum cleaner. So when you turn on together, also the same. Okay, so for the vacuum cleaner is also transient, okay, considered as transient state. So it will have a sudden spike, then it will slowly go to steady. So we will see the sudden spike as a feature, and then we recognize it. Okay, and then the right one is switch off together, so also able to recognize, right? So all these overlapping events still able to this system still able to recognize and then still able to provide the appliance level result, right? So yeah, so to summarize, this developed system, okay, that integrates the random forest is for the steady state detection, and then the LSTM with attention is with the transient state recognition, and then last one is the scenario specific algorithms. So like all the to handle some special case, for example, your transient, for example, your multi-state or on together. Okay, so we can see from this case, actually this approach is better than relying on, for example, only in a single model. That is more compared to this, the hybrid one is more effective in tackling the load monitoring issue. Right, so in future, so we may more focus on like adding the voltage or power feature. Okay, this is to like enrich the signal, also to improve the classification accuracy, but we need to look on it because the more feature you adding, then you need to have a stronger computation power. So we will see how to balance this, right? And then next one is to increase the sample size and then to expand the appliance categories. So this one to make it more generalized, for example, like adding more appliance and maybe collecting more data set will also like help us to test the system under a more diverse and also a more realistic condition, right? And then last one is the improve the spin cycle detection. Okay, this one is mostly target to the washing machine because like washing machine, you will have a very complex multi-stage cycle. The the early washing cycle and the spinning is two different feature. So currently we are able to detect the washing part, but the spinning part is still not that stable. So this is one of the future that we need to improve, right? So also to better to capture the transition, the continuous transition as well. okay, can make this system more comprehensive. All right, so that's all from me. So yes, thank you. Is there any questions?
Thank you, Dr. Tan. So now I open the floor for questions. Anyone have a question? It seems like there's no question from the floor. So thank you so much again, Dr. Tan, for your sharing. It's quite interesting, but I guess I am not so familiar as well. But I know it's a electrical thing in Paris and whatnot, right? So thank you,
Okay,
Dr.
thank you.
Tan.
Thanks.
So we can now continue to the next presenter. Hello, hi there.
Hello. May I know the next presentation is me?
Yes, correct. You are right. You now can share your screen.
Okay, sure.
Thank you.
Everyone can see my screenshot.
I can't see your screen.
Okay. At the moment. Can next presentation first. I will configure my laptop. Maybe have some problem for sharing the PowerPoint.
Okay, all right, I understand. So, can we move on to the next presenter? Next presenter will be Dr. Tan Sing Jin, but I think unfortunately, she's here.
Dr. Tan is in, Farah.
Yes, I saw Dr. Tan there. I couldn't contact her.
Oh, okay.
Hello, I'm here. I'm here. Is it my
Hi,
turn?
Dr. Tan. No, it's not your turn actually, but the student have some difficulty to share the screen. Would you be able to go first?
Okay, okay. You give me a couple of minutes. I need to open the PowerPoint.
Thank you so much, Dr. Tan. Okay.
Okay, give me a couple of minutes.
Yeah, sure.
Can you see my slides?
Yes, Dr. Tan.
Okay, okay. Okay, I will start my presentation now. Good afternoon, all, to those who are present here today. So I'll be sharing this, my work with the title Light Polarization Control with a germanium bismuth telluride thin film. Okay, some lights, they are actually visible and some lights, they are non-visible. Nevertheless, they have the same properties, okay, such as amplitude, wavelength, frequency, phase, and polarization. They are measuring instruments that can be used to measure these properties, such as optical spectrum analyzer and also radio frequency analyzer. Among all these properties that I have mentioned just now, light polarization is something that we rarely focus on. Light polarization, okay, they can actually be categorized into linear, elliptical, circular, and circular. Just like the other light properties, light polarization can be measured as well using instrument called polarimeter. Azimuth and ellipticity are the two parameters that describe light polarization. The figure here represents a Poincare sphere. It is a 3D representation of light polarization. Azimuth defines light polarization in the XY plane, while ellipticity describes the shape of the ellipse. Any point on the Poincare sphere, they actually correspond to a specific light azimuth and ellipticity. In short, if we view the 3D Poincare sphere as a globe, the azimuth represents the longitudinal, while the ellipticity represents the latitude. Okay, on the right, it is the light polarization in the 2D view. Okay, this particular light in the middle, okay, only has azimuth component, while on the most right, okay, it has azimuth and ellipticity. Okay, light polarizer may be found in many applications such as sensing, imaging, communication, and material analysis. When you are outdoor, okay, during the sunny days, all of you, not all, maybe majority of you will be putting on your sunglasses, right?
Okay, the sunglasses that you are wearing, it is many of them are polarized sunglasses. The function of this sunglasses is to actually reduce glare. It works by allowing only certain light polarization to enter our eyes. Okay, in atmospheric LIDAR sensing, polarized light is used to sense water droplets and also ice crystals. Ice crystals, they are actually non-spherical in shape. The non-spherical shape and birefringence nature in ice crystal, they actually scattered light in both the original and also orthogonal directions. In contrast, spherical water droplets, they are very symmetry in shape, hence they maintain the original light polarization of the incident light. Okay. Hence, water droplets, they actually give low depolarization ratio because they preserve the incident light polarization, while ice crystal, they will give high depolarization ratio. This high and low depolarization ratio, it can be used to identify different shape of atmospheric particles. Okay, in view of this, okay, we are actually working on this light polarization. How can we control light polarization using some novel materials? Okay, to actually control the light azimuth, okay, and also the ellipticity. So in this experiment, we have laser diode, amplified spontaneous emission source, polarization controller, wavelength division multiplexer, and a polarimeter at the end to analyze the light polarization. The material that is under investigation is this thin film material, germanium bismuth telluride. I have my collaborator that actually supply me this material. So these are the results that are captured in a 2D and also 3D dimension view. So on top, it is the light polarization in 2D view, and at the bottom is the light polarization in 3D view at different pump powers. So we can see here the azimuth, it is actually changing in 2D view. So initially the light is in the vertical direction. As we increase the pump power, the light polarization rotates in anti-clockwise direction. Here at the bottom, in the 3D view, if you can see the blue dot on the screen, okay, initially it is at the center of the Poincare sphere, or we can call it a globe. So the little blue dot is moving from the center, okay, to the left. So in 2D direction and also in 2D dimension and also 3D dimension, we can see that as we increase the pump power, the light polarization rotates. So in this case, the azimuth is actually changing, but the ellipticity or the ellipse is somehow maintained. Okay, so from here, if we plot azimuth versus pump power, we can see that the azimuth is changing from negative 89.92 degree at low pump power all the way up to negative 71.26 degree with total rotation 18.66 degree. Okay, if we actually plot the linear line, okay, we have linearity R square of 0.9879. So as we increase the pump power, the temperature variation introduced by the pump power actually modifies the birefringence, okay, through thermo-optic effect, which in turn change the phase between polarization component and subsequently alter the light polarization state. Okay, coming back to this graph, the efficiency of rotation, it is 0.0531 degree per millivolt. So on the top right is the formula showing the relationship between change of temperature and materials refractive index. So the thermal optic effect here, it changes the materials refractive index with temperature variation. In some materials, this will alter the birefringence and actually resulted in shifting of light polarization. So for ellipticity, there is a small fluctuation, not too severe. So it is the maximum one is 0.91 degree and minimum is negative 0.73 degree. So as we can see here, the azimuth is rotating more than the ellipticity. So we can actually use these characteristics to do some sensing application. Okay, moving on to the next slide, the ASE peak wavelength we also studied as well with the increment of pump power. Okay, we can see that on the top right is the 3D plot of the injected ASE line. So we can see that the wavelength is actually quite constant, very minimal fluctuation in the wavelength that we are concerning, around 153 something nanometer. Okay, the ASE peak, it is also quite constant, around negative 13 dBm. Okay, as a conclusion, so the total light rotation, we can actually rotate up to 18.66 degree. Okay, even though this rotation is not really significant, but somehow this material shows a response to light. Okay, and the rotation efficiency is determined at 0.0531 degree per millivolt. Okay, the linearity is also okay, not too bad at 0.9879. So as a conclusion, this work can be actually used for some applications such as sensing and also material analysis. Okay, that's all for my presentation. Thank you.
Thank you, Dr. Tan.
Thank you.
Okay, I now open the floor for questions. If there's any questions to Dr. Tan Chin. I think there is no question from the floor at the time. So thank you for sharing.
All right, thank you very much.
Okay, thank you also for coming in early. So okay, now we will continue with the next presenter, Islam. Are you ready?
Yeah, is this my turn?
Yes, it's your turn. You can share your screen, your slide.
Okay, is my screen visible right now?
Yes. Okay, you may start. Thank you. Happy presenting.
Okay.
Eh, oh, I'm sorry.
Sorry?
Is it Haj Hamad?
Yeah, it's me. Yeah.
Okay, so just now, not student is actually having difficulties. So, Dr. Tan take a step and do the presentation first. So you will be going next. It should be, oh, how do I pronounce your name? Yang Mutian. Are you there?
Yes, I'm still here.
Okay,
Everyone can see my screenshot.
it is your turn
Uh,
right now, and then we'll be continued by Haj Hamad. Yeah.
okay.
Can you? Yes,
If you have seen my screenshot.
yes, I can. We can, but can you make it a bit full screen
Okay.
maybe the present the slide?
Okay. Okay. Hello everyone.
Hello. Okay.
Today I will introduce my. Okay. Hello everyone. Today I will introduce my topic. It's about synthetic feature selection with LLM, primary oil price forecasting in low soft market. Generation say my research title is about using the ChatGPT and LLM large language models to do some the feature selection ways. Because now in low source market, for example, too many countries don't have a huge GPU and CPU to do the feature selection. We using the GPT or LLM large language model to try to do the feature selection ways. Firstly, I will say something about the background of the primary oil pricing. The primary oil in Malaysia is called the second black god. Every year we make too much money in Malaysia. But some feature will influence the primary oil price. For example, the international, the global marketing, global stock. But how to catch the losses market, the price forecasting price is become more and more important. Look is this is a range of the primary oil pricing in Malaysia. It looks it's a tense. It's not it's not too smooth. And the next, compare the traditional method with LLM large language models. The method was different, and the traditional method, for example, the MI lasso and IFE, the feature selection ways, is a basis about the number and the corrections. The data, the image is canvassing the means our fate and the strategies. It's available with a big data. The provide the weight is a large language models. There's no need due to deal with the large data, and no need due to clean the data. They will spend more source about the GPU and the CPU. Next, we introduce the workflow for our for our research. Firstly, we will connect the data. The influence the primary oil data is are using for the finance data, open source data, and later we connect data to some of the data pre-processing
You, for example, exchange the title for the CSV to Excel. And next, we were using large language models protein to deal with the feature. And after the prompting, we will give the feature the LLM scoring, and next we will to choose the best feature to the next broadcasting. And for the traditional ways, we were using the traditional MI way and the RFE way and the lasso way to do the static feature selections. And after the finish the forecast the feature selection, we will add the XGBoost models. XGBoost models is for the forecasting models to compare to evaluation the result. And the dataset feature, we using the Yahoo Finance open source data, and they have some data for the committees and the exchanging rate and the financing indeed. And for the put large language models, firstly, this is some coding for the LLM models. Firstly, we ask the question about the prediction context. It's about they are predicting whether the Malaysia primary oil price increase the month, and give us some rate. For example, the rate is important. Give the value 0 to 1, which one is important. And this is a research hardware to software configuration using the AMD CPU and the NVIDIA RTX 3060 GPU, and the memory is 32. And the software are using the Anaconda. For the result, we choosing the different way, different the data set. For example, firstly is using the primary oils data set, and I also using the GLOT to compare. We can show the result first. The large language models can make the very good accuracy for the forecasting, and we using the got the to do the forecasting, and they will also give the good accuracy for the forecasting results. Totally, they will up the maybe the up to 58 percentage MAC and 36 MAC and the MAE to the increase the accuracy. And this is for the result. For the forecasting result, you can see the LM models can get the high accuracy forecasting result. And this is a compare the method for the different the feature selection ways. We also can see the LLM large language models and get more forecasting accuracy. In conclusion, we using a ChatGPT 4 find the meaning for economy features, and second, the performs traditional method in accuracy and stability, and the third one is provide
interpretable and practical forecast. Last is workwear is the low source market. The future, my opinion, for the user language model to do the figure selection with only a single method. We need to keep the accuracy. Next, in the future works, we need to using the hybrid model. I mean the large language models plus the another way to do the hybrid model, and they have a very important ways is large language models. For example, the ChatGPT, the training data is up to the 2024. If the training data is not very new, how to training the new data. This is a future works we need you to consider. That's all. Thank you.
Thank you so much for your sharing. So I now open the floor for Q&A. Is there any question from the floor? No question from the floor, it seems. Thank you so much again, Ouyang Mutian, for sharing your paper. So we are actually going to have a session on 11:10 because as what we schedule will be toilet break right now. So okay, so is Teacher Professor Dr. Lee Jin Chong, would you like to continue the session or you would like to continue again on 11:10 as what we schedule?
Yeah, hi Farah. Yeah, I think I can just start my presentation. Is it fine?
Okay, yeah, fine by me. Is everyone, I think everyone is okay. Thank you
Okay,
so much.
all right, let me share my screen first. Thank you. All right, can you see my screen?
Yes.
All right, thank you. Good morning, everyone. What is my presentation title about is the dual camera image processing approach for aid classification in smart agriculture application. All right, for information, this project is actually done by my final year project student, and it's actually a pilot program for upcoming progress development. So what I presented today is actually part of the progress. All right, let me start my presentation with some background information. All right, the order of the works here is actually the first one is Zikian Cheng is my final year project student, and then me myself and Dr. Tan, Dr. Sim, and also Dr. Ko. All right, we have presented this work in one of the conference on clean water, air, and soil in roughly in August. Okay, and some of the background about this project is about the eight grading. All right, why we try to develop a system to perform this eight grading because of the critical quality control in the relevant poultry agriculture industrial. And to ensure the aid meeting the requirement to reach the customer in the sense of size, weight, shape, and also the shell quality standards, uh, a proper organized or automated aid grading system is actually quite crucial. Uh, Existing traditional way, in fact, we are using the manual inspection in most of the small scale industrial. Uh, the problem facing in this industrial, especially on the labor intensive issue, where a, a number of workers that will be required in order to do all the inspection, and hence time consuming also another issue compared to the automated method. And then last but not least, the manual inspection basically prone to human error, all right? Especially on the human labor work for substantive long duration, the worker may get tired, all right? So that's why we try to propose a solution to tackle these three major problems. Okay, so here is some of the importance of a consistent and high quality A grading requirement. So the first one is to maintain the product uniformity. So if let's say we try to classify the A as a grade A, grade B, and grade C, so we need to make sure that the uniformity is there. All right, and then the second importance will be the fair pricing. All right, so we need to ensure that not only on the shape itself or only the size itself, but also the weight and the quality itself need to be ensured as well. All right, and then the last one is to reduce the risk of substandard eggs entering the market. All right, so in short, basically we need to ensure that the consistent and high quality egg can reach to the market. All right, so the challenges which to tackle this issue is how to implement an automated system that can minimize the reliance on manual label while utilize more objective and biologically relevant metrics for the system to enhance the grading precision. All right, so here is the proposed solution. Right, develop an approach aligned with the poultry industrial needs, right, especially on the category of the poultry farm eggs that already predefined in the industrial. And then also the approach that we mainly propose the solution towards automation and also smart manufacturing practices for the small industrial, and then ultimately contributing to the increased uh, productivity and sustainability. Right, the key aim for the proposed solution is to integrating multi-angle imaging. So which means that we are using more than one camera to capture the image. And then afterward, we will need to perform the geometry analysis and also the machine learning based classification. So our hypothesis about the proposed solution is the use of dual camera inputs, improve measurement robustness, and overcome projection distortion. Meanwhile, the proposed algorithm support vector machine model should provide a reliable and scalable classification mechanism with high predictive accuracy, even with a small data set. All right, so here is the step number one on how we actually come up with our solution. The first one is to complete the dual camera imaging system. So during this stage, we develop and implement dual camera imaging system, which is capable to acquire two views of the eight images. One is from the front view, another one is from the side view. All right, afterward, we will basically use this capture image to perform geometry analysis and with the aim to have accurate classification and also minimize projection distortion. All right, after that, we perform the image pre-processing. All right, so if you take a look on the diagram here, basically I have the camera 1, which is the front view, and then camera 2 basically is the side view. Okay, so there are few processes that we need to actually gone through to pre-process the image. So the first one is cropping, resizing, and also grayscaling, and then followed by the edge detection and the feature extraction. So if you take a look on the feature extraction stage, basically there are three features that we need to capture from the front view. So the blue color we call as long polar radius, green color line we call as short polar radius, and the red color line we call as equatorial radius. So based on these measured metrics, we will use this information to basically calculate the volume and also the surface area, the surface area and cross-sectional area. And then the second view, which we capture the cross-sectional diameter in order to get the cross-sectional area. All right, so by this, basically we model the egg as the composite ellipsoidal structures. So we expect these features should give us more accurate recognition or classification on the egg grading. All right, so here is the algorithm which we have deployed, all right, which is quite a general classification method called support vector machine. All right, so we try to classify the eggs into 4 categories, which is popularly in the market. We have grade A, grade B, grade C, and grade D in Malaysia. All right, so we train the model with these 4 categories with the predefined features. And then after that, we do some testing on the deployment to capture the images from the real view. All right. And also we try to do some extension on the result after classification, whereby the microcontroller based sorting mechanism has been attached to the outcome of our recognition system. Okay, so if you take a look on the diagram here, we have infrared sensor 1, 2, and 3, and also infrared sensor 4. So correspondingly to the detection of the appearance of different grade of the eggs. So we have bin A, B, C, D, where this is the storage that we are going to put different grade of the eggs. But anyway, this is actually the prototype that we try to do a testing, not the complete system yet, right? So the preliminary results and the finding at the current stage, we found that the accuracy by using SVM can achieve more than 97% classification accuracy. And the measurement error is actually less than 1.6% in dimension. And the real-time validation also confirm the system reliability in dynamic condition, especially on different lighting, because we have putting the lighting system during the image acquisition. And then in terms of the sorting mechanism, also it has demonstrated the scalability for small to medium scale farms, which means that we can basically put in different size of the beam, and we can fit in maybe larger scale of the farm agriculture scale, right? So that is our expectation, all right? At the moment, we just test it on the small scale. All right, so as a conclusion, this project basically have already developed a fully functional and high accuracy egg classification system, which is potential for small and medium farms. All right, and then the strong potential for integrating the entire image, the egg classification system into a broader smart agriculture system, not only in the poultry industry, maybe we can make it into other agriculture industry as well. So moving on for the next step, we may need to improve the environmental adaptability, especially on multiple eggs that to be put into the conveyor belt and to have a higher speed on classification as well. So which we haven't taken into consideration in our current stage. And also we may need to integrate the feedback-based sorting as well, especially on the egg counting for different grade, all right, for broader agriculture application. All right, thank you very much. That's all for my presentation. Thank you.
Thank you so much, Associate Professor Dr. Lee. A very fast presentation. So I now open the floor for questions. Is there any questions on the floor?
Good morning, Dr. Lee.
Yeah, morning.
Salina here.
Yeah, hi.
I just want to know, what is the average time that you take to actually trying to measure one egg? Average
You mean
time.
you mean from the image acquisition until the result to become out?
Yeah.
Based on what we have done, roughly less than 30 seconds. All right.
Oh, okay. That's fast. Yeah, okay. Okay,
But
okay. Thank you.
yeah. All right. Thank you.
Thanks.
Right.
Okay, thank you, Miss Salina, for question, and then also Dr. Lee for sharing this interesting topic about the egg. Okay, so we will actually continue again for because next presenter will be Dr. Tangkot Lim. I believe he has something at the moment, so we will start again at 11:30.
All right. Thank you.
Okay, thank you so much. Hello everyone. So now is 11:13. I shall now invite Associate Professor Dr. Tan Kok Lee to present his paper.
Okay, let
his
me start.
finding.
Okay, sorry, I just finished my talk only.
Yeah, no
Sorry.
problem.
Okay, okay.
No problem. Yeah, thank
Let me share
you.
the slide.
Sure.
Okay, can you see the slide?
Yes, we can.
Okay, I start.
Yes, please.
Okay,
Thank
basically
you.
my title I'm going to present is impact on e-service quality on consumer loyalty in Malaysian e-banking, and there's a mediator. This mediator is customer satisfaction. You look at the trend here. Basically, we are talking about the transformation from traditional banking to digital or e-banking here. Formerly, we use traditional. Normally, this one we go to physical branch and do the transaction. But with the e-banking, basically what we need to do now is very seldom we go to bank branches. What we do is do online. So basically, you can see here. I think from here, the first bank who start the e-banking is in year 20 in year 2000 by Maybank. This is the first bank they start the e-banking. That's almost 25 years already. Okay. So with this e-banking, normally the transaction we do in e-banking is mobile banking, internet banking, and automatic banking system. Here you can see the trend here. Basically, you can see the volume. The volume you can see from year 2016, which is 449 million transaction. Right now, you go back to look at 2022, the transaction is 1.5 billion. That's according to the statica of 2023. Therefore, the increase is quite huge. Therefore, e-banking is very important. Okay. The problem statement here basically I split into two parts. First problem statement we are talking about with the e-banking, it has reduced the barrier switching between banks. What does it mean here is customer tend to switch bank to bank without realizing from the bank because everything do online. Therefore, this is what called problem faced by the bank. With this, the bank not only difficult to attract customer, but also retain the customer also have an issue. That's the first problem segment. The second one, we are talking about security and privacy. Right now, I think we more or less we hear a lot of certain why the bank account is drawn by somebody else. Therefore, with this security and privacy also another issue. Okay. The third issue here I can see here, if let's say you want to upgrade, the bank want to upgrade the system into integration of advanced technology like AI, big data, and cyber security, they need to spend a lot of money. Therefore, it's a cost concern. So these are the three major issues that in the problem statement I'm going to address. So from here, I'll come up with a research gap here. The research gap, basically, you can see here, the impact of traditional banking on the loyalty has been the subject. Very much less. People normally do the what I call the article. Normally they go direct one. That means in this case, here I'm talking about I go in, add in one mediator. This is called customer satisfaction. I think you can see a lot of article. Normally they do go direct. They call e-banking quality. Again, loyalty. But here I'm introduce another mediator. It's called customer satisfaction. Okay. So another gap here because the research that I do is only in northern Malaysia, which is I do the survey in Perlis, Kedah, Penang, and Perak. These only 4 states. Okay. And the research objective basically I divide into 2 parts here. The first 3 objective I'm looking direct impact means direct impact the e-service quality. E-service quality here consists of 3 elements. The first one is responsiveness, reliability, and security and privacy. So the first three objective I go direct means the what they call the e-service quality affect the customer loyalty. The second objective is 456. That is another set. I'm going to look at the mediating between customer satisfaction, the relationship between e-service loyalty and also the what they call e-service quality. The research question also the same thing. Okay, the underpinning theory here, basically, you look at the traditional type. Normally, they have a traditional service quality. They have these 5 elements. So with the introduction of e-service, they call e-secure here. Basically, I'm going to look at 3 particular elements, which is very important: responsiveness, reliability, security, and privacy. Okay. And for this particular one, I look at this literature review for these 3 very important elements, which is service quality. The first one, we are talking about responsiveness. Responsiveness, basically, we are talking about the promptness and efficiency address customer inquiry. Try to resolve for the customer. I think this particular one is very important because everything we talk about customer service, right? The second element I'm going to look at is the reliability. Reliability here, we are talking about make sure the customer expectation seamless and error-free. I think for the customer, especially we're talking about money, because banking, normally we talk about monetary term. It's very important for them to make sure whatever money they save in, the money is them, not go to another account. Okay, that is the reliability. And the security part also very important. Security part here, we are talking about confidential ability and integrity of customer data. Make sure the data I keep in the bank, make sure this particular data will not go into another place. That is very important. These are the 3 areas I'm going to look at. Okay, let's look at the mediating here. Mediating, basically, these 3 particular elements, here I'm talking about customer service, I'm talking about responsiveness, reliability, and security and privacy here. These 3 elements, I'm looking how they mediate the customer satisfaction. Okay, you can see from the result here, basically this one is consistent. This customer evidence support to customer satisfaction mediate the relationship. So therefore, you can see the value here. Let's say we talk about beta, we talk about p-value. These all are consistent. Okay. Then for reliability, we talk about customer service mediate the reliability and the customer loyalty. Again, you look at the p-value is less than 0.05. Therefore, it's significant. The third one, we are talking about security and privacy. The relationship also, you can see here, the p-value is less than 0.05. Again, this is consistent. This is significant. Okay. And the theoretical framework here, I'm going to look at 2 parts. First part, I'm going to look at direct from e-service quality to customer loyalty. There are 3 elements: responsiveness, reliability, and also security and privacy. Another set I'm going to look at is the mediator. Mediator here, I'm talking about how this customer satisfaction mediate the e-service quality and customer loyalty. That's H4, H5, and H6. Yeah. Okay. The methodology, research methodology, basically I divide into a few parts here. The first part, we are talking about the research population and sample size. Basically, you can look at the study done by this CAMP 2024. There are total of 22.17 million online customer user. Okay. Then the sample size here, I take only 166 using G power. And the sampling method here, I'm going to take is a judgmental and non-probability. and also I'm doing the snowballing method. Okay. Therefore, I say for this particular study, I take only from 4 states, which is Perlis, Kedah, Penang, and also Perak. I send out the 212 valid respondent, but the usable one is 166. Okay. And the research methodology here, I divide into few parts. The first part, I'm doing the demographic descriptive analysis. Here, I survey the gender, age, education, income level, and occupation. And the descriptive data descriptive analysis, I'm doing the mean, median, and mode. And the normality test here, basically they survey on the curve, the bell curve. So how I survey, I'm doing skewness and also courtesy. So you can see the benchmark here is -2 to +2 for skewness, and courtesy is -7 to 7. Therefore, you can see my result here is within the what they call the benchmark lah. And then the next one I measure is the factor analysis. Factor analysis here basically I'm measuring to to explain the relationship among the largest number of observed variables. So you can see here, the benchmark, the first component is less than 50. Therefore, I get 49.23, and the cumulative is more than 50. I get 76.6. Therefore, it's within the benchmark. And the next one, I'm also measure the validity here. Validity, basically, I'm measuring the accuracy of the variable. So from here, you can see the KMO is the benchmark is more than 0.6, and the significant level is less than 0.05. And my actual result come out is stood at 0.906, and the significant is 0.0001. Therefore, it's within the benchmark. The next element I measure is the reliability test. Reliability test basically measure the consistency of the variable. Okay. I'm using Combat Alpha. Therefore, you can see the benchmark is more than 0.7, and my range for all the variables is between 0.748 to 0.918. Again, it's within the benchmark. And the correlation, later you can refer to the report that I'm going to explain next slide. And the regression analysis, the value is according to the benchmark must get less than 0.05. Again, you look at my result here. I have 3 variables. The first one, 0.316, which is not significant, and the other 2 is significant. The other 2 is less than 0.0, less than 0.01, because the benchmark is so-called 0.05. Again, I say the first one, responsible is not significant, and the other 2 is significant. Okay. The last item I measure is the mediation analysis here. Here I'm going to measure the indirect effect of p-value must be less than 0.05. Again, later you see the result, which I get is the 3 variable which I measure is less than 0.05. Okay. Therefore, this now I see you look at the what they call the multilinear regression analysis here. I'm looking at the R square. The R square is 0.558. 0.558 means can be explained these 3 variables: the responsibility, reliability, and security and privacy. Explain 55.8% variable in the customer loyalty. And the next one I measure is I look at the p-value. Just now I did mention the first one is insignificant, it's 0.316. The other 2 is significant because it's less than 0.05. My result here showing 0.001 and 0.001, which is significant. The next one, I'm looking at the mediating analysis now. The mediating, I introduce a customer satisfaction insight. Therefore, you can look at the result here. The first column, you can see here the indirect effect of customer service. according to the responsiveness, this one indirect, the figure here shown, the effect is 0.222. Therefore, it's a partially mediate the relation between responsiveness and customer loyalty. You look at the second element, again, I say here is 0.360. 0.360. Again, this is a partially mediate the relationship between the reliability and the customer loyalty. The third element, security and privacy, you look at here is 0.19. 0.19. Again, this particular one shown a partial mediation between the security and privacy and the customer loyalty. So the result, the testing in final result here, the first one is insignificant. The reason is significant because it's more than 0.05, which is I got the result during my testing, I got 0.316, which is rejected. Okay, and the rest of the three are accepted because it's is within the range. Okay. And the discussion about between the independent variable and dependent variable here, this is direct one, direct relationship. The responsiveness and the customer loyalty is insignificant. Just now I say insignificant, the first one. The reason is customer does not really concern about the responsiveness of e-banking when they come to loyalty toward the e-banking services. This result can find align with the existing literature. These are the two literature that I found. Okay. The second element is reliability. Reliability, this one is significant. Just now we already shown in the earlier slide is significant. And this one indicate that the customer has high education level, tend to emphasize on reliability on the banking platform. Again, this one I found some finding which in line with this particular finding. These are the article that I read, that I found. And the last one is the security and privacy. Again, I say this is significant. It's less than 0.01. Okay, and this one, this result indicate that customers tend to utilize online more frequent, and thus safeguarding their financial information relative to crucial to them. Okay. Again, I say I find this one from these three articles. This in line with them. Okay. And the mediating factor, that means the customer satisfaction in relation with IV and DV here. Again, I say this is in indirect effect, customer satisfaction mediate between responsiveness and also customer loyalty. This result tell us a strong positive relation because it's in less than 0.05. Again, this finding is in line with the existing literature. Okay, reliability also same thing here. While reliability is key driver of loyalty, the positive impact, again, I say this is just now you look at the result also strongly positive relation, right? Therefore, again, this finding I found it from in line with this three literature. Okay, the last item is security and privacy. Again, this security and privacy, enhancing the security and privacy in banking as a strategy to improve customer satisfaction, which ultimately foster greater loyalty. Again, I say this is a positive relation. You look at the result earlier, it's positive relation. And this finding, I also found it from in line with this two literature. Okay. Okay, regarding the implication study, I divide into two. One is theoretical implication, one is managerial implication. The theoretical implication here, you can say this one will impact the advance of knowledge. This one will mediate the customer satisfaction, which I impose into this particular study, and also the context of relevance, and also the core nuisance framework, and also the applicable evidence. The other part, managerial implication, this one impact the customer quality enhancement, focus on customer satisfaction. Then we have a training development, feedback mechanism from the customer, and also the try to improve the strategy innovation. There's some limitation in the result. Here again, I say because I survey only 4 states only, which is not enough lah. There is a limitation, and also the sampling. Just like I say, you see the population so big. I only take 160. Therefore, the sampling is constrained lah. Okay. The third one, the time limitation. I took only about 3 to 4 months to do this particular area. Therefore, the time is limited. And the sample size, again, I say is 166 is not enough. Then about the scope of dimension here, basically we are talking about the level at which the dimension data is collected. Okay. Then self-reported data is also one of the limitation because this one is without a direct observation. And the last one, cross-sectional design. Here, basically, we are talking about the time taken to come out the outcome is insufficient. In conclusion, basically, you can see from the study here, we can know that the e-service quality dimension, customer satisfaction and customer loyalty is very significant and mediate the customer satisfaction. This is the first part. The second part, the result shown that the responsiveness is not significant. The rest are all significant, right? Just now I saw of which 6 measurement, 5 direct and another 3 direct and 3 mediation. Only 1 is not significant, which is responsiveness. Okay, suggest that the bank might prioritize other areas lah, instead of going to have a so-called focus on responsiveness. Okay. Next one, the conclusion is the reliability and security identify a key positive. That means these 2 variables are very important. Okay. The last part here, the insight gain, the contribution, both academic and also practical strategy. That's why I come up with theoretical and also theoretical implication and also managerial implication. For bank, pathway to enhance customer loyalty to increase competitive digital banking landscape. These are all the references I got it from. Okay, that's done.
Thank you so much, Dr. Tan.
Any question from the floor?
Okay, we now open the floor for Q&A.
Anyone?
Alrighty, thank you for sharing.
Thank you. Thank you,
Okay,
Farah.
there's the
Thank you.
you're welcome. Sorry, Dr. Tan, there's the question from Farhana Aini. Okay.
Yes.
So, can you share more on the snowball sampling technique?
Snowball sampling, basically here I'm going, let's say I send out to one particular respondent. This respondent will help me to what we call to do so-called to help me lah. Instead I'm doing send to one by one. So I ask another respondent to help me to send out the survey. This is called snowball sampling.
To forward it.
Am I answering your question?
Farhana Aini, is Dr. Tan answering your question? Yes.
Okay.
Okay.
Thank you.
You're welcome.
Thank you. Okay. Can I stop the sharing, Farah?
Yes, you can.
Okay. Thank you. Thank you much, everybody. Thanks for
Thank you.
listening. Thank you. Bye-bye.
Alrighty. So now we will continue the session with Haj Ahmad. Haj Ahmad, are you there?
Yes, I am.
Okay, you now may share your screen.
Okay. Is my screen visible right now? No?
Yes, we can see your screen. Topology, optimization, and structural analysis. All right. The floor is yours.
Hello, everyone. Yeah, my name is Fatih Osman. I'm a master student from the School of Engineering. And good afternoon. Yeah, today I'm going to present my research paper under topology optimization and structural analysis for uncopter drone frame design in SolidWorks. Basically, we can start by a little bit introduction about drones. Drones, also known as unmanned aerial vehicles, which has gained popularity and utilization in the last decade and predicted to be more and more in next 10 years. The drones used in different application, commercial and industrial, for the drone like delivery and construction expansion and different application. The problem or the drone challenge nowadays is the drone weight, which indicates the total mass for the drone, including all the components and payload and the additional and the electrical components for the drone, which can impact the flight performance for the drone and payload capacity and the endurance for the drone and flight time. Yeah, by this challenge, the drone faces a lot of problem. In this paper, we introduced topology optimization, which is a technique we can help us like to find the optimal weight for the drone without compromising the structural integrity for the drone. As I said, the drone has many classifications. Yeah, in this paper, we more focus on multi-rotor drone, and in multi-rotor drone, we more focus on autocopter. We choose autocopter over the others multi-rotor drone because the drone we are designing right now is for the delivery purpose. So it can carry heavy payload, and also it is for the delivery. It's more operational resilience and professional mission. So you can use it also in the other industrial application, like as I said, with copter drone, more stable in the air than other multi-rotor drone. Our objective from this research is design and optimize quadcopter drone by using SolidWorks and implement topology optimization technique in SolidWorks, and then get the optimal structure weight for the drone. Expected outcome from this research to enhance the performance for the drone, which we can reduce the total weight for the drone and then enhance the payload capacity and the flight time. Also improve the stability for the drone and get lightweight drone frame for practical application. Yeah, this is the topology optimization overview about topology optimization. Topology optimization, basically, it is computational design method determines optimal material distribution with a design space. It's work to eliminate or to minimize the weight for the part without compromising the structural integrity and get the optimal weight for the part you created. Starting by the design the 3D model in any software, we are using here SolidWorks, as I said, then implement finite element analysis, which is a method we show us how the part will react. The purpose we implement topology finite element analysis before topology optimization. We show us the area has a lower stress and lower displacement, so we can eliminate it without affect our part. After conducting topology optimization, we can move to redesign our part again. And finally, we validate the drone, the design again by using finite element analysis and ensure all of stress and deformation or displacement within the limit we have. Here is a finite element analysis. As I said, it's like simulate the structure response and show us how we react to real life situation. Also, we show us the displacement and stress distribution in the part, which we can rely on it to design and test the drone before manufacture or before fabricate our part. The FEA methodology, it's related to, or it's doing like breakdowns the design in small elements and calculate both of stress and strain and displacement in each element, and show us area has a lower stress and low and high stress. So the area has a lower stress, we can remove it without compromising, as I said, the structure integrity. This is the methodology overview. The methodology of this paper is starting by the designing the drone frame, which, as I said, it's a quadcopter drone frame designed in SolidWorks. Then we select the material, which we choose here PLA, and we can also, after select material, we should determine the thrust force. Thrust force is for the drone. It's responsible to take the drone up or to lift the drone and be able to fly. Then we conduct finite element analysis to show the area has a lower and high stress level. And then we conduct topology optimization. So this is all the methodology we are follow in this paper. Here our design. The design starts by designing several parts for the drone. It's including drone arms, and bottom cover, and middle and top cover, and leg bracket, and combining all these parts together. As I said, the drone has 8 meters. 8-meter configuration. It's a symmetrical structure, and we illustrate the payload integration for the drone, and each arm has a 45 angle between each arm, which is the optimal design for the quadcopter drone frame. The frame specification is started by knowing the original drone weight, which is around 1.6 kilogram. This is a drone weight without the electrical component, which is really critical for us to know it before conducting topology optimization. Then, as I said, we select PLA. As we know, PLA is costly friendly for prototyping and eco-friendly, and also it's easy to print and fast to print. We can use it as a prototyping purpose. Here, this is the mechanical properties for PLA we use in this paper, which indicates the yield stress and maximum deformation, which is really critical factors in designing for the structure, which we can help us like to indicate all the part with the limit for PLA material. Here, this is a calculation for the thrust force. So thrust force for each meter, we can calculate it by this equation. The total weight for the drone with electric component around 1.5 kilogram. As I said, we have quadcopter drone, so the rotors or the thrust force per meter will be around 600 gram. It's equal after we multiply it by the gravity, so we get the thrust force per Newton is around 6 Newton for each meter. Yeah, this is a thrust force calculation for our drone, which will help us like to implement this thrust force in the software in SolidWorks. So after that, we get the result for finite element analysis. This is finite element analysis process, starting by the designing. You have already designed it. After that, we have to create mesh. Mesh, it's really critical step in, and also it's really important for doing good finite element analysis. It's responsible to divide to model in small elements. After that, we will be able to predict or to know the drone or to know the stress in each element. After that, we apply the boundary condition for our part, and then apply the load, which is thrust force. I have already seen in the last slide. And then we conduct stress analysis. Here, this is a specification for the mesh generation. After that, this is the process for conducting finite element analysis, for conducting topology optimization, which has 5 important steps, starting by creating the 3D modeling we have created already in the last step, and then set the objective for conducting topology optimization, which is minimize the weight while maintain the structural integrity or the strength for our part, and then apply the load and constraint, which is the truss force and the boundary condition for our parts, and then run the topology optimization. After get our final part, we have to redesign the part, then conducting finite element analysis to ensure the part has safe and acceptable limit. Here, our result after conducting topology optimization. Here, the initial drawn part, or the original design, and here we have the optimized design for the drone frame, which indicated we have around 32% weight reduction, and while maintain and increase the payload capacity by 500 grams. So it's increase the payload capacity, and we have got like 32 weight reduction. After that, we have to conduct finite element analysis to ensure our part is safe and can the drone fly safely, without facing any failure or risk. This is also this validation result for the finite element analysis for the drone, which we can see, which we have like to know all the stress level and deformation for all the drone part with acceptable limit for the PLA material. As I said before, the acceptable limit for both stress and deformation, for the stress 49.5 megapascal, and for deformation around 4.7 millimeter. So here this is the result for our drone parts after conducting finite element analysis. This is stress and displacement analysis or deformation analysis key findings. We can see in this table all the drone part, the maximum stress and maximum deformation with acceptable limit or allowable range for PLA. All the stress or the maximum stress for all the drone part with the acceptable limit. That means the drone is safe and can fly without facing any failure, or also ensure the drone is stable during the flight, and maximum deformation. Also for maximum deformation, also part with acceptable limit ensures the structural integrity for our drone. To conclude, the study has successfully demonstrated the effective of using topology optimization in SolidWorks to create lightweight drone frame and get around 32% weight reduction and increase the payload capacity by 500 grams, and validate the drone parts and ensure all the parts with acceptable limit for the material we have selected, which is PLA. This here our reference we used, and thank you for listening. I'm looking for your question.
Thank you, Azama, for sharing. So, now open the floor for Q&A if there's any question.
Is there any question?
It seems like there's no question from floor. So thank you so much for your sharing. I will, yes. So you now can continue to the next presenter, Miss Alina binti Muhammad.
Hello, good afternoon. Can you
Hello.
see my slide?
Yes.
Anna?
Yeah.
Okay, so can I start now, Farah?
Yes, sure. The floor is yours.
Okay,
Thank
thank
you.
you. Good afternoon, everybody. Thank you for listening and joining the seminar. So I'm presenting not mine, actually my student and me, my FYP student research on design and optimization of a 5-stage CCDD. CCDD stands for cross-couple differential drive rectifier for RF energy harvesting using Intel 16 technology. So these are my team for the research, my student Hong Wei Jian, and postgrad student Li Yizi, myself, Dr. Tan Sin Jin, Mr. Mason, Dr. Goh, and Prof. Yap. And this project actually is funded under internal grant from Penang campus. And the Intel technology actually being sponsored by Intel, of course, and it is actually in Penang campus. So this paper is presented in the 13th International Conference on Robotics, Vision, Signal Processing and Power Application in Penang on the 2nd and the 3rd of September this year. So moving on to my content, so just like usual, some introduction and why we are actually using this circuit and what are the results that we have found. So for introduction, I'm going to go a little bit on radio frequency, why we actually choose radio frequency as the application for testing the circuit, because RF stands for radio frequency. So nowadays we have a lot of communication going on surrounding us. So there are a lot of RF wave, yeah, radio frequency wave around us. It's just that we cannot see them, but it's actually a lot. And it is actually in a form of continuous signals, and it is one of the source that is becoming very popular nowadays, to be found that can be harvested. Yeah, so the signals that is the RF signal that is around us that's not being used can be harvested and converted to some sort of a power source. And the focus also for the project is that because people are nowadays IoT, Internet of Things, have become so popular, and many of the devices that is mobile, that can be mobile, need batteries, yeah, to power up, because we cannot really depend so much on the power supply. So when it comes to battery, so one thing is you need to replace them often. Secondly, they might contribute to a huge amount of e-waste. So when we harvest something that is around us for free until now, okay, so it actually can save the usage of the battery, because these devices, some of them are not using that much power, yeah, but you still need a battery to supply it. And so moving on to what we call as energy harvesting, technically we want to change, okay, or we want to what we say take in the RF signals, and using some sort of a circuit converter and all to change it to a DC output. Yeah, DC we know is a direct current, so it can be used to charge your phone, to start up small devices. Yeah, so it can be mobile. Yeah. And from all this, the RF, the IoT, the energy harvesting, how can this CCDD circuit or rectifier circuit that we are investigating on come into place? Because this circuit, the CCDD or the cross-couple differential drive rectifier, okay, it's actually a circuit that a form of a AC to DC power converter, meaning the continuous signals that we get from the RF, the continuous power source, okay, we convert it into DC power so that we can turn on, okay, this mobile, these gadgets that we are bringing along. And the thing is with this circuit, yeah, the rectifier circuit that we are optimizing is that it produces a high power conversion efficiency. Okay, currently there are few rectifier circuit, but you know, when you want to convert the either the RF signals or any other signals that around us, to convert back to DC, the efficiency is very low. You will get some output, but the result will not be as optimum as we expected. And it also have a low on resistance characteristic, which is somewhat important in electronic circuits. And also it has a small reverse leakage current. So when you have lesser leakage current, you will have higher efficiency. Okay, so what is actually a CCDD? So CCDD, as I mentioned before, is actually a AC to DC power converter, and it's actually first proposed by Kotani, Sasaki, and Ito in 2009. So the thing is, you can see that is the first circuit design that was proposed back then, and it consists of several transistors. We call it as a CMOS or the complementary MOS transistors. And the thing with CMOS is that it can easily be integrated into IC, the chip, not our identification card, it's the chip. So and nowadays we know that all the small gadgets, they are actually depending on the chip, which is on the motherboard itself. So if we want to have additional CCDD circuit, it is easily integrated into it because it can be manufactured or fabricated using the same CMOS technology that is used to make an IC. And there are parameters that we want to observe that can be observed from the circuit. First is the power conversion efficiency. Second is the sensitivity, voltage output, and also the dynamic range. So during our optimization, these are the parameters that we are observing to make sure that the performance of our circuit is meet some requirements. And along the way to optimize, we are actually having a few manipulated variables. Yeah. So among others are like coupling capacitor. Okay, so you can see from the circuit, actually coupling capacitor is the input capacitor as well. Load resistance, load capacitance, yeah. And then we also have what's the value of multiplier, what type of biasing we are using at the circuit, what kind of transistor model that we are using, how many numbers of stages we can cascade, okay, the circuit itself to make it high efficiency. We also include the impedance matching and also the inductance values to make the circuit even more optimized. Okay, so why actually we use CCDD? Among other rectifier that is popular nowadays are the Dixon and the shock disc, yeah. And of course, they have advantage and disadvantages as well. But it turns out that from research, the CCDD is actually somehow theoretically proven to have a higher power conversion efficiency, meaning the efficiency to convert the signals or the power that we have around us to the useful output source or output values, yeah, is higher compared to the other types of rectifier circuit. And with that, yeah, and because of the why we not why we are thinking that the energy harvesting is a very good area to tackle nowadays because of the power. People are fighting to about power now. How you want to supply power to your mobile devices? Yeah, so energy harvesting is a very popular research. So in order to make sure that the energy that we harvest from the in this case from the radio frequency itself can be converted as much as possible or as high efficiency as possible. That's why we are trying to test it with the CCDD. And one of the thing now is that even though it is known as having high efficiency, it is still not fully commercialized, okay, in devices or in any gadgets. One reason because of complexity of the circuit and so on. Yeah, so as many researchers are trying to do or trying to make this circuit to be can be embedded in the commercial devices. So that's why we are also actually jumping into the wagon to try to find a way to optimize it. Okay, and our objective for this presentation, or maybe up until the conference, so we want to find the foundation, yeah, how actually it how can the circuit efficiently works, yeah, and then we want to find whether 5-stage is enough for the rectifier, because of course if we go higher might be better, but it will have a lot of cost, yeah, because more circuit means more area means of course more materials and cost, and how you want to fit it into the motherboard and so on the chip itself, yeah. And so for methodology, because as I mentioned before, we actually have support from Intel, and they're actually providing us with a PDK and IPK16 software, as well as a Cadence Cadence layout suite. So it's actually a software where we do the simulation, yeah, do the simulation of the circuit itself in terms of a transistor level, and we convert into layout levels. Layout levels means a layout levels which is ready to be fabricated. Yeah, but unfortunately we have not passed the hardware fabrication yet. Yeah, some problems with it. So from the supplied software itself, we are actually running out 3 types of analysis, which is the scattering parameters analysis, harmonic balance analysis, and the normal popular one is the transient analysis. So for the scattering parameters analysis, we are actually focusing on one, especially on one component, which is called S11. So it is actually it shows the power reflected back to the port, the ratio. So the lower the ratio means the better it is, meaning that whatever signals that come in will go through the output, and very much less will be reflected back. Okay, so if you, it's really impossible to get 100% coming in to go out. Yeah. But if you have 100% coming in, and if you have like at least 90 or 80% going out, you only have reflection of what 10 to 20%, meaning your efficiency is very high. Okay. And for harmonic balance, is actually want to see on the frequency range, yeah, of the signals. And of course, usually transient analysis we use to look at the rise time, yeah, meaning how fast your circuit actually can respond to the conversion, yeah. We also don't want to have a slow response circuit, yeah, because it means that as you go along, yeah, you will take time to get the supply back for your application to your device and so on. So we want a very fast response, or we call it as a rise time, as well as the ripple voltage, because as we convert something that is continuous to something that is direct, definitely there will be some attenuations. Yeah. So if the ripple is too much, it will give you a not stable kind of output, which is dangerous to your devices. Okay. So besides the analysis, yeah, we also try to modify or varies, yeah, a few variables to see which one is going to give out the most optimized output. So we have 6 variables, yeah. First is the transistor model itself, because the package that the Intel provide us actually allowing us to test with a different type of transistor model. So we can see which one is better. And we also look at biasing type. Yeah, either we have a bias or we don't have a bias. Number of stages, meaning how many times can we duplicate, yeah, the rectifier circuit. And also we look at the load capacitor value, multiplier number, how much we can multiply the output, and also the value of the load capacitance and the input capacitance and the load resistance, yeah, coupling capacitance, yes, coupling capacitance, sorry. So from actually the project itself is run in cadence, yeah. So we have to draw circuit, transistor circuit, and we run, and when we say we do the variable testing, meaning we change a few values, a few transistor model in the software itself, and then we run, we collect the data, and we compare. So the first result that we have is the when we are testing the circuit, yeah, the CCDD rectifier circuit with different transistor model that we have in the Intel software, as well as the IM network, the impedance matching network, the value of the technically the inductance inductor value. So we have about 7 types of transistor model in the software. Generic means the normal ideal kind of transistor. HP is high power. HS is high speed. HSLT is high speed, low threshold. LL is low leakage. LLLT is low leakage, low threshold. TG is thick gate. Okay, so these are actually the type of transistor that is available in the package. So we try with all types, and we found out that the one that given the highest value of the S11, not the highest, I mean, because it's negative, yeah. So is the LLFTT, so the low leakage, low threshold transistor model. And we try with a few values of inductor. We found out that most of the model actually runs very what we say at the best, okay, at 5 nanohenry inductors, yeah. So for the analysis later, the 3 analysis later, we will use a LLLT transistor model with 5 nano Henry inductance impedance matching, yeah. And then we look at biasing. So we just run it with no biasing. And then we have a bulk biasing, bulk gate biasing with 1 capacitor, and then we have bulk gate biasing with 2 capacitors. And we find out that actually the bulk gate biasing with 1 capacitor gives the good value for the S11 value, but the output and the efficiency actually kind of lesser than the other biasing. So after certain consideration and after few tuning, we decided that we stick with a no biasing configuration, because technically there's not so much difference in the output, and to make the simulation easier, so we decided not to do any biasing to the CCDD rectifier circuit. And also we have a number of stages. So we target it to be 5, but we try with 1 stage until 7 stages. just to see whether the 5 is within the acceptable range or not. And we found out that it does, okay, because you can see when it goes to 6 stages, the sensitivity become lesser, okay. And so we, after the simulation, we decided to stay with 5 stages of rectifier circuit. And the load capacitor, okay, this is a bit tricky part because a capacitor, usually the values are not very varies, yeah. So we decided to have a certain points of capacitor value to be tested. And we can see that the output, yeah, or the ripple voltage, ripple just now I mentioned, is that when we want to do conversion, they will have the output will become attenuated, yeah. So we can see as we increase, yeah, as we increase the value of the capacitor, F stands for femto. If you're wondering what is F means, for F is femtofarad. If you're wondering also what is femto, femto is 10 to the power of minus 15. Okay, so it's very small. And as it goes, as it increases here to 1 picofarad, pico is 10 to the power of minus 12 farad, yeah. So you can see actually the ripple becoming smaller, yeah. But the issue is when you increase the capacitor, the rise time becomes slower. So the response, yeah, the time taken to achieve the value or the conversion that you want is very slow. So we have to compromise between the ripple voltage and the response times. Of course, we will have to have a fast response as well, because if you have a slower response, then there will be a lot more problems like, you know, what we say, delay, and then you will have more losses, yeah. So after some consideration and more tuning, so we decided to stick with 100 femtofarad for the load capacitor. Okay, taking into consideration the acceptable amount of ripple voltage with the what we say good response times, yeah. And the next one is the number of multipliers, yeah. So we test with 8 multipliers, yeah. And we found out that the voltage slightly constant around 4.4 volt for 1 multiplier to 4 multipliers. And when it goes to higher multiplier, yeah, at 0 dB value, the output voltage actually reduces, yeah. And to make sure and to, I mean, to just make sure that the output is can sustain a very high kind of output. So we decided to have a maximum multipliers of 4. Okay. So beside multipliers, the last one is what we call as a coupling capacitor. Yeah. So when we run the coupling capacitor with about 10 values, different values, we found out there's like actually no trends. Yeah. No, no what we say equal trends, yeah, with every value. So it's very difficult for us to choose which value is the one that is you know, giving the most reliable output. So we consider mainly on the DR, or the dynamic range, yeah, the dynamic range of the response, as well as the efficiency of the respective capacitor. So again, we choose to have 100 femtofarad, just like the load capacitor just now. Because one thing, it has the highest efficiency, yeah, and also one of the widest dynamic range, around 11.7 dB. Okay. And then the other value is the load resistor as well. So you can see from the graph, the load resistor actually giving a somehow equal trend, yeah, not like the coupling capacitor just now. So it's a little bit easier for us to choose the value, yeah. But we actually tested for a range of from 10K until 1 mega ohm, yeah. And the one that we show here is actually around 50 kilo ohm to 200 kilo ohm. So we eliminate the one that with the lower input, yeah, because it means lower range. Low. We don't want a low input power, and we also have to eliminate the higher range of the resistor, yeah, because the efficiency values, yeah. So we choose a natural value in the middle, which is 100 kilo ohm. Oops, sorry. So after completing the testing of the variables and monitoring the performance parameters, yeah, using the software, so we found out that these are the design choices that actually give us the most optimized output, yeah, for the 5-stage CCDD. So our final design is we are doing it on the layout mode, meaning we do it in the what we say in terms of if you want to fabricate it into the IC. Okay, so a final design looks like this. Yeah, you can see all the green color is actually all the transistors. And they are arranged somehow and then connected to the power source and so on. So the core itself, actually the size is about 23 micrometer times 26 micrometer. Yeah. So the chip is actually very small. But then because we know when we have a chip, it has to be, put in a casing itself. Yeah. So we have a padded, we have the power pin out and so on. So considering all the power supply and all, we have to not we have like it's actually the size is increasing to 221 micrometer times 234 micrometer in size, which is still considered small. Yeah. And we try to fabricate, yeah, but there's a bit of problem with the Intel APK files. We somehow cannot access it and so on, but we still hope that we can fabricate and test it as a hardware, yeah, and compare it with the whatever simulation that we have done. So conclusion, so we managed to get until 65%. Of course, as I mentioned, 100% is very impossible. 65% is considered good because you need to harvest it from surrounding, yeah, and slightly good dynamic range as well as the output voltage. So yeah, that's all for me. Thank you.
Alrighty, so we will open the floor for Q&A. Is there any question?
You're welcome.
Okay, so if there is no question from the floor, thank you so much, Ms. Helena, for sharing.
Thank
So
you.
yes,
Yeah.
so now
Thank you for
we'll
listening. Thank you, Farah.
you're welcome. So now we will we continue with our second last presenter. Associate Professor Dr. Sim Hock Cheng, are you there?
Yes, can you hear
Hi.
me?
Yes, we can. So you now may share your slide.
Okay, can you see my screen?
Yes.
Okay, so good afternoon, everyone. So this is a paper that the presented in a Clean WAS conference. So the title is In Pipe Water Turbine for Hydropower Generation in High-Rise Building. So it's actually there are three keywords here. That's where a water turbine is hydropower, and the context is actually for high-rise building. So all the while, every day we are talking about sustainability. We are talking about green energy. And now it's actually there are some study actually have been reported that one of the study also actually published by WWF. So it actually stated that hydropower is actually destroying Europe rivers and biodiversity. Because we know that to build a big hydropower project, it is actually you cannot find a place. You have to create the environment, and then you may destroy the environment. And that's why actually that's the statement of WWF. And the statement here also mentioned that hydropower generally produce clean electricity, but hydropower does affect the environment because of we need to change the environment, we need to change the landscape, we need to modify it so that we can build our structure. So that's why because of all the shortage of all the natural waterway, you do not see the trend is actually going to, we are not looking into the giant hydropower plant now. They have been looking into any possibility for us to actually create or to set up a small or even a micro scale hydropower to actually generate electricity and not to modify the environment. In fact, I actually even plan to have a small micro hydropower at Badakawan campus at the retention pond. But the question is because of retention pond, you cannot install external thing, and then the project I didn't proceed. So hydropower is good because they actually producing clean energy. But then hydropower devices may not good because they impact the environment. And we are moving into small and micro is very simple because it doesn't require extensive modification of the environment. So we try to actually look into, can we actually tap in the existing structure, existing system, and generate electricity. So this is the whole idea of how it start the things. And then we come into the next one, we are talking about high-rise building. That most of us or the two campuses, we are actually located in Penang, and then we are located in Shah Alam Grammar. And if you look around us, you look around us, the Penang area, Shah Alam area, KL area, you are aware that we have more and more high-rise building. And that's why I just mentioned that. With the increase of the population, we need more high-rise building, and they become higher, they become bigger, they become more. And if you're aware that how we get the water supply, that in the high-rise building, gravity storage tank, most of us, we have a big storage tank at the top of our condominium and all the high-rise building. And how the water actually being supplied is you need energy. You can see that the red color, you need energy to pump from the supply to the water tank. And then how the water tank supply the water to the daily use, they actually supply through gravity feed. That's why we need energy to pump it up, but we don't need energy to distribute it. But the question is, all this gravity feed, they are actually the energy we lost. A little bit of science, we are starting with a potential energy. And then when the movement, you go into the kinetic energy. And the whole conversion energy is actually energy loss. Because you just imagine that if we going up, if we go now, if I need to supply again, I need to add additional energy. So the idea comes in that with a loss of high-rise building, so is there any possibility for us to tap in this structure, install something, and then we can harvest the energy? So we don't want to modify the environment, but we want to think of a way to harvest additional energy, or from a non-productive energy to a more productive energy, because it will be a loss. Energy never disappear, but it will be just lost and then distributed to the environment for nothing. And this is just a little bit statistics. That if you can see that the numbers of floor per building on average in Dubai were very high. New York, Hong Kong, these are all high dense, but even other cities, they also. Now the question for us to ask, in Malaysia, I don't have the statistic, but if we are actually in Penang Island, especially, or if for my KL campus colleague, though, if you go around KL, if you drive around the Shah Alam area, you can start to look into all the new projects. In the past, 10, 15, 20 floor is considered high. But now, a lot of projects, they are looking into 40, 50, 60, even in Malaysia now. So it means that we have a lot of this kind of system that water going out with energy, water coming down without energy. So this is actually the background. And for this project, students have actually reviewed different turbine design. There's the Bonjoring design, or a design, a Pelton wheel design by Lee. And then another design is by Stellar in 2022. After we consider, we have decided to go for this design. Because other design, you need to have a more drastic modification. You have a lot of external structure that you have to install in addition to the turbine. So you actually modify the piping system a lot. But then the Stellar design is actually you can have the whole system on inside. Or let me reconstruct the diagram. Imagine that this whole thing is actually moving down. So the water will be supplied from the top. This will be your supply. And then this will be to your house or to the user side. And because of gravity feed, that's why we install the whole turbine here. It will be here. And then it will actually spin the turbine. So by this, we can easily modify our existing structure. And during my conference, there are actually some of the audience actually ask, what happened if there's a breakdown? What happened if the performance drop? With this design, very simple. We may just replace the whole part. If you look into the piping, there are always a way of us to replace the piping that have broken. So you can actually use the existing structure, use the existing approach, and install that for a simple or small energy harvesting. Although one input or one turbine is small, just imagine that we are talking about multiple level. Imagine that in every buildings you can install 5 or 10 this kind of thing. The accumulated energy will be huge. So that's why after we select that, the reason we're selecting Stellar is actually due to the easy of maintenance. And in order for us to do analysis, we study or we identify a few input consideration. Why we consider that? Because we have to understand what is the actual. We have to consider that we don't design something that cannot be implemented in the real case. So we actually consider that the actual flow rate, we assume that is 1. The water pressure is 200 kPa, and the diameter is the diameter of most of the pipe we are using to supply from the water tank to the household, that we are taking those with the diameter of 96. So after we identify the input, this is how it has been discussed. So there's initial design, that's where the water will supply in and water go out, and then this is where it will spin the turbine. So we try to have this design by referring to the reference that I mentioned just now. And after that, we identify a few design consideration. That the constraint that we have fixed is actually diameter have been fixed. And then because it's a circular, we cannot have too big that increasing the friction or cause the cause the friction and then affect the movement. So that's why the internal diameter is 96. Our external size, we actually fix it to 95 with a very tight tolerance. And next, what we need to decide is actually how to design the blade, or each of the blade, how we actually, the type of the blade, the size of the blade, that's where our design comes in. For us, there will be 4 criteria for us to decide. The angle of the blade, this means how the twisted it, and then how many blades are we going to have it? I'm going to have 3, 4, or 5, and then the width of the blade as well as the thickness. That's where This will be the width of the blade, and this will be the thickness of the blade. And then this will be the angle of the blade. And of course, another one will be the quantity of the blade. So we identify 4 variables that we can adjust, we can study. And after we develop the analysis, the calculations, that the decision of final design is actually the angle is 20 degrees Celsius. There will be in the total of 5 blades, and each of the blade with 15 mm width and then the 2 mm of thickness. And then in order to actually connect them and enable the rotation, we select a 10 mm dot at the top and at the bottom to connect everything. So to connect all the blades together. And with this one, you actually reduce the edges of the turbine, a smoother finish, a better water flow, and then we achieve a better efficiency for that. So this is actually the final design on the top view and the side view. So you can see that water will flow in, they'll rotate it. And the good thing is again, because when we supply water from the top, we are not sure that whether they'll be in this side or in this side. And this kind of the blade, it allowed the blade to spin in either direction. And of course, we have done some simulation analysis that we can see that you actually in the center part, you allow the water to flow through, and then actually there will be a rotation happening in. And this is the stress analysis, the velocity analysis. That's where there will be a changes on the at the center part. And we also perform the pressure analysis that we do not hope to have a loss of blockage, and then of course it can spin it, but then it affect the water supply. So we try to have the balance between harvesting the energy and supplying the energy. With this design that is still able to spin it, but then the pressure will not drop too much. We will still keep the constant pressure. Because in the original, it should be at the lower and then it should be higher pressure because of the differentiation of the height. And then with this thing, we're able to maintain, and the differentiation of the height, we actually convert it into the energy that we can harvest. And then after the simulation analysis, the estimate output for a blade with a particular input and output, our output energy is 85 watt. And then our overall is 29 to 70.79%. You may actually know, ask, what is the 85 watt? Some of the LED light will be using that it can be even the 15, 20, or 40 watt, which means that every single thing of that you can actually use that to immediately power up the lighting system. It can be very useful because in all the high-rise building, we need the lighting system for our corridor, everything. So this system is not for energy storage and use in any other place. It can be a buffer for you to actually to power your existing devices that is not high energy consumption, and then it reduce the dependency on the supply from the grid. So this is the conclusion. With a surplus water head, the pressure reduction valve can be replaced by in-pipe turbine while maintaining the flow condition. This is why the idea is actually like that. I can just replace the pipe with a section like that, and then I can harvest the energy. And then if anything you need to service, you need to exchange, you need to maintain, you can just replace the pipe. So this is or we call that design for maintenance. Whenever we do any design, I don't only design that I can use. We have to design that if something goes wrong, can we easily do the service? Can we easily replace? Can we easily maintain? So this is actually a one way of design consideration. And of course, this is not the end. The idea is actually what I want to do is actually we would like to perform a real experimentation analysis. But of course, it's always very challenging because I cannot or very difficult to find a real building for you to modify their piping, install something to do the testing. So another direction will be more on the research. That's where in the initial blade design is actually is a flat. It's a flat design. So it means that with a flat design, and then only that we only have thickness template. But now in the future, we are running, rather than using a flat design with a standard cross section, we try to do a hydrofoil system. With this modification, change the tip speed ratio, change the cord length, everything, we may able to get a better efficiency. And then we may even looking into, currently I'm trying into the one turbine. In the long run, I may even want to study in a one high-rise building if I install multiple turbine. What is the impact? Or should I have the same turbine for different level, or for different level, I can have different turbine design. So this will be the future research recommendation. The experiment is not really very complicated, but then the idea is actually how we can harvest energy from what we have around us, and not to create something just to do a harvesting and damage or alter the existing environment. So that's all from my side. Any questions?
No question for me.
Yeah.
So is there any question from the floor? So Mr. Lina said it's a very interesting
Okay.
project.
It's very interesting. It's not so technical. Although inside very technical, I try to make it to be simple so everyone can understand. The idea is actually because we always talking about green, and a lot of time when we do green, we try to install something to be green. So the idea is we don't want to change to be green. We want to harvest from the existing resources. We want to minimize the impact.
By the way, Prof. Sim, what is the materials you are proposing for the turbine?
This one is actually we are still starting with the alumina because we not go into material because material will actually affect the durability of the system.
Yeah,
But
yeah.
now we are still focusing on the size first.
Okay. Thank you, thank you.
Yeah.
All righty. So
Okay, thank you.
thank you so much. So last but not least, we will have Dr. Y Gayam. I think you're muted.
Right, yeah.
Hi,
Okay.
hello. Okay, so
Good
now,
afternoon.
good afternoon. Floor is yours.
Yeah, good afternoon to fellow researcher here as well. So today I will be presenting, let me share the slide first here. Okay.
Okay, now I am hungry.
Okay, please
Because
bear with me.
to the
Okay, so
lemang.
I'm the last one. Okay, so okay, so today can you see my slide here?
Yes, you can see
Okay,
it.
okay, yeah, very clear. Okay, so I will be presenting this research title that which is modernizing lemang with mushroom floss for sustainable food security. So of course, this is not I'm not the only I mean the one that who do this study. Actually with the help of other co-authors, Dr. Alicia, so sorry, yeah, Dr. Alicia and Noor Shahida, which is my FYP student. So okay, let me do an introduction about my project first. Okay, so lemang is actually a traditional Malaysian glutinous rice dish that usually we cook in bamboo, and usually we it's a very symbolic roles that when it comes to Hari Raya celebrations. So through this study, actually we aim to modernize the lemang while we're trying to maintain the cultural identity and the heritage. So back to my topic again. Today, we are trying to modernize the lemang, and also we have another aim is actually for sustainable food security. So why come out this thing is because when the global demands evolve, actually sustainable food security has become a focus in redefining the food equations. So what we call as a sustainable food security is actually means enough food for all, and it is nutritious and safe for consumption. And lastly is the most important is about the continuous production. So what is considered as what actually we call as continuous production means that the way the food produced will actually will not bring any harmful effect to the environment. And besides, the supply of the food can continue for our future generation. So these three are actually the key attributes to the so-called sustainable food security. So the objective of our study, actually, we have two, okay, which is very simple for the FYP project. Actually, this is a project that conducted by my student. So we have two main objectives here. The first one is actually to develop a frozen